So everything should be the same except that I cannot broadcast to your desktop terminal, okay? Okay, let's get started. Good morning, and okay, today we are going to Unit 4, and the topic of this week is R in action. Now, you already take some action last week, right? In your homework assignment, you have 3 homework, right? The first one is the digital detective. It's about the car stolen event in the Chicago city, right? Okay. The second one is stock price. You have stock price, long-term stock price, right? And the third thing is the census data, right? So you already have done some exercise, right? So today what I'm trying to do is kind of like walk you through all of these 3 cases, okay? Uh, if you take a look at of our syllabus, it's something like this, right? So in this week, we are doing R in action, and see, actually we are behind of schedule. Usually after this regular R built-in command, I will also teach you 2 very important package: the data frame manipulation package and also the visualization package, right? So we are kind of like 2 weeks behind schedule, but don't worry, we will try to accommodate. We will mitigate that uh, using some time in the probability, right? Because I think that we don't really need to learn a very, very advanced probability. Only some basic concept of probability will be enough. We won't even use well, it's very seldom that we will need to use the inferential statistic technique that you learn from Li Chengxian 老师. So don't worry too much about that. So I think we can like pull 2 weeks out of probability and do some more R, right? Do some more R language, okay? So today is the last week that we will do the built-in R functionality. And starting next week and the week after that, we will do some add-on package, some add-on package, a very important add-on package on R. And then that would pretty much do it. You can tell the other that you already can use R, right? Okay. Actually, you're already using it, right? So back to today's game plan. The 3 cases, um, I draw them from the MIT online course, right? So this is actually uh, the first week's assignment of MIT's business analytics course, right? They uh, they have a very very uh, intense course in MIT. So I would like to we need to slow it down, right? So as you can see that although even though they are the first week assignment, they are not easy, right? When you try to answer it, it's not that easy. So I'll walk you through. But each of this unit has some uh, learning objective. There are some key concept that they actually build in these 3 cases. In the first case, we are talking about day and time, right? And day and time is a very troublesome data type, as you might have experienced, right? Already in the case. We will learn how to use day and time, and we will have more exercise on table and t-apply. Okay, so if you can use table and t-apply, uh, you can almost finish all of these 3 assignments by using table and t-apply. Right? if you can use table and data point. Okay, so these are the most important two built-in command in R. And then now in the second case, we will do some time series data because it's stock price, right? Long-term stock price. And we also learn how to use line plot, multiple line plot actually. And then the last thing is actually, well, I kind of do it wrong. Sorry, it should be something like this. Okay, this should be correct, right? Okay, and also in the second exercise, um, we'll also learn one more apply series function, right? We already learned T apply, right? There's a sister function called L apply. Now this to apply function is the core of R, right? It's the core of R. And actually, these three functions um, was available in R in the first in the very beginning. In the 1980s, when I used S in Bell Lab, they already have these three commands, right? So and if you can use these three commands, if you can use these three function code, then basically you can solve like 85–90% of the business analytic problem. Okay, so that is the second case, and in the third case is the census data. We are dealing with NA, and we're also dealing with merging data frame, right? Okay. So how many of you have already finished all of these three assignments? I mean, we are in team, right? We do it in team assignment. But the way you should do it is like get together and do the assignment together, right? So how many of team did get together and do the homework assignment together? None of you?
We did, but some question we cannot solve.
In some session, right? You should try to get together and do the homework assignments together, right? Um, Especially for the beginner, you should not do it at home, right? It's like uh, don't do it at home because um, you will make some very little mistake. For example, you misspell something, right? And it will take you like an hour to find out the misspell thing, right? So to do it together uh, for beginner is very important because otherwise you'll get stuck in a very stupid thing, right? And you'll waste a lot of time just to solve a very minor problem, right? So try to get together, use our TA time, and try to work together. So next week you should already upload one version of the software into the assignment folder, right? Right. So and this week after we walk through all of this, you can update your assignment and upload the correct answer. Okay. So that is the game plan. But as usual, before we go into the today's uh, content, I would use to do some review, right? Okay. Still remember what we learned last week? The major thing that we learned last week is actually the comic character data set, right? And we also play Kahoot game on the end of the class last week. And someone asked me to upload the answer of the Kahoot, and I did, right? So you should see the answer there. Um, but I would like to revisit that data case to kind of like to warm up everybody so we can get into today's class. So if you scroll down, uh, again, today's materials here, right? You can download the material and like what you should do is you should unzip the data and put the folder in the same label as 02, right? This is 04, right? So you should unzip the data and make the folder in the same label as 04. It's the same label as etc. And that should, then you should be able to like knit all of the notebook um, without problem. Okay, so let's take a look at this comic data set again. We will go back to this data set again, right? We will use it again and again. So the first time we use it is to remember what we did last week. We we have a data set. The first thing is we want to examine. We take the summary of the data set. For each of the variable, we would like to see. We would like to examine each of the variable. What do we mean by examining the variable? If the variable is a numeric, we would like to see its distribution, right? And if the if the variable is categorical, then we want to count, right? We want to count each category and see how many point is there in each category, right? It is the very beginning. In the very beginning, when we get the data, this is the first thing that we want to do. And then we start to get into the complicated things, right? We are using table, we are using t-apply. Well, actually, when you use t-apply, two things are involved, right? When you use t-apply, it involves two things, right? For example, I want to see uh, the ratio of bad guys. I want to see the proportion of bad guys in blue-eyed characters, right? So you have two variables involved, right? First thing is the align, right? Is this guy good guy or is this guy a bad guy, right? So this is the first variable, and then and the second variable is the like eye, right? Eye color, right? So you have two variable involved. Right? That's where the complication kick in. So I would like to start today's course to bring you back to that table and t-apply thing and kind of like warm you up before you go into the today's material. It's actually here. Now, given this question, what is the fraction of male in blue eye color? I mean, in the characters of blue eye color, what is the fraction of male, right? Okay. If you want to answer this question, two variables is involved: eye color and also sex, isn't it? Right? So you want to see the uh, fraction of male. It is actually the mean of sex equal to male, right? Isn't it? If you want to see the fraction of male, you actually take the mean of sex equal to male, right? That's basically what you need to do. But how about this blue eye color? So if you can use index, you can actually use index like this, right? This is an index, and with this index, you'd actually uh, filter out you actually filter out the non-blue eye colors, right? Isn't it? So this expression is actually the sex of all of the blue-eyed, isn't it? Right? I mean, this expression is actually the sex of all of the blue-eyed, right? So I test this vector with male and then take a mean. Now this is the answer, right? This is the answer. So if you write this way, you don't really need to use table or t-apply, and you will get the exact answer, right? You will get just one number to answer this question, right? So use index is the first thing that I have told you, and that is the one more important thing, right? Now using index, you can answer the question very precisely. Now the second way to answer this question is to use t-apply, right? Okay. Say because I want to see the fraction of male, right? So I take mean to the fraction of male, right? And I do it by blue, right? I test the eye color equal to blue. So I have two numbers, right? If I do it this way, instead of one, I will have two numbers. So this number is the fraction of male in the blue-eyed, okay? So what is this number? Let's, do you have the, do you have the gift to send out? Okay, good. So what is this number? Now, t-apply is to apply the function to this vector by type, right? By type. So this type is blue color. And how about this one? Because this expression would evaluate into true and false, right? Isn't it? So true is blue color, and what is false? Mm-hmm. Good, other colors. Raise your hand so I can send you the gift. Okay. Who answered the question? Okay. Okay. So instead of one number, now we have two numbers. The reason that you need two numbers is you want to compare, right? Isn't it? If I just has one number, I only know that this is the fraction of male in blue-eyed, right? When I have this, I actually can compare whether the blue-eyed color has a higher ratio of male or the non-blue color, isn't it? The reason that you want to use table t-apply is because you want to do group computation and then compare between them, right? Do group computation. The purpose of group computation is to compare, right? In your homework assignment last week, a lot of exercise uh, involved comparison, right? The largest, the the least, the right uh, involve comparison. So when you involve comparison, you want to do group computation and compare the results, right? Okay, so if you do t-apply, you'll get two things, and then you can compare the blue-eyed and the non-blue-eyed, right? And if I do it this way, right, I replace this expression. Actually, it's even simpler, right? So what do I see here,
show every
right?
color. If you show every color,
Right, show every color. Show what of every color?
eye color,
No, no, no. What?
or fraction.
对, the fraction of male, right? You show the fraction of male. Still seeing the fraction of male, right? In every eye color, so you can compare, right? So you can compare. Uh, which eye color has the largest fraction of male? Can you see that? Raise your hand. Red, right? The red color, the red hair color has the highest uh, probability of male, right? Isn't it? Okay. Now, does it mean that uh, in red color, uh, there are more red color male than blue color male? Now, blue color is like 0.64, right? And red color is 0.80, right? Now, by seeing this, but by this comparison, can I say that we have more red color male than blue color male? Can we say that? No, you're right. No, no, we cannot say that. But why? Because this is actually fraction, right? Because they are the red color people is like maybe just 100, and the blue eyed color maybe like 1,000, right? So even though that it's just 64% of blue color, of blue eye color is male, then because its base is much larger than the base of red color, isn't it? Right? So when you do this, you are not comparing the number, right? You are comparing the fraction. So that is the thing that we want to distinguish. Okay? Okay.
So we have to use some. If we want to know.
Yeah, yeah. If you want to count the number, then you need to replace this mean with sum, right? Okay. Okay. So this command, I mean, this function call is very very sophisticated, right? So if you can use it right, you can answer a lot of questions. Okay. Now the next thing, if we do table on sex and I, right? Okay. Let's get back to RStudio. Okay. So if I do this right, if I do this expression, this is actually the count, right? Because table, right? It count the uh, female black eye, female blue eye, right? Uh, it count the numbers. Now, if I want to turn number into fraction, into proportion, I need to determine on which direction I want to turn it into fraction, right? If I turn it into fraction in the second, I mean in this way, right? Then I'm testing the fraction of male and female, right? Isn't it? So if I do it 2, right? It actually every column would add to 1, right? So when I do proportional table 2, I'm actually doing proportion in this direction, right? So when I use 2, actually I'm calculating the fraction of male and female in every eye color, right? Isn't it? So if I do it at 1, it's different, right? Right now I'm counting the right. Right now I'm counting of what? What is this number? I mean, because I'm doing proportional table in this direction, so this number would add up to 1, right? Okay. So what is this number? Raise your hand. Yes.
It's just showing the percentage of each eye color within, like across only female. So it's
Right, you are right, you are right.
all the
It's
different.
actually showing the
Unfortunately,
fraction of eyes, right? The fraction of each eye color in female, right? Isn't it? And same thing is this is showing the the fraction of each eye color of male, right? Female and male. So depends on if you use table, you need to be careful, right? Okay. Depends on which way you do the proportional table. It's you need to interpret the number differently, isn't it? Right? Okay. So in this exercise, let me, uh, we don't have too much time to practice, but I suggest you try to answer this question. It's not easy. I'm doing two, right? So right now I'm testing the fraction of male and female in each eye color. So, so which of the following statements are correct? Can you do a group exercise now? Like discuss within your group, like and find out which of the following statements are correct. Okay, I should put an S here. Okay, I'll give you like 1 minute to discuss. Uh, be careful, I'm doing it two, right? So right now I'm testing the ratio of male and female in each of the eye colors, right? So you get your answer yet? Need more time? So which group has the answer already? Raise your hand. It's it's not easy, isn't it? Is it easy? It's not easy, right?
The question is complicated.
The question is like it's question is not complicated. We are saying this every day, right? This is like our everyday natural language. But You just cannot think it carefully. When we put this question together, start confuse you. Right? Um, let's try to do. We have 14, right? Let's have the 14 answer each one of this question, right? Team one, is this right? Where is team one? Yeah. Male are more likely to have red hair. Is that right? No, it isn't right, right? Because because the because right now the base of comparison is not is in this direction, right? Proportional to, right? So we cannot compare, we cannot do comparison in this direction, isn't it? See what I mean? When you have proportional table 2, the, you can only compare the figure in this direction. You can no longer compare figure in this direction, right? So when I say male are more likely to have red hair, you are saying you're doing comparison this way, right? So that's wrong. Okay? Okay? So yes. Sorry? Ah, sorry, you should have I. Yeah, sorry. Uh, sorry, I get should be I. Okay. Okay, so first one is wrong. Where is team two? Where is team two? Okay. So is team two correct or not? Is statement two correct or not? Yes, right? Yes, no? Yes. The reason I say yes is because now we are comparing uh, male with female, right? So and that's is compatible with this direction, isn't it? How about team three? We have more red eye color female than any other color. The same thing, right? You cannot do comparison this way, isn't it? Okay. How about the fourth? Is it yes or no? Yes? Yes, right? Even though what we show is actually the proportion, right? But inside eye color, the higher proportion, the more people they are, isn't it? Right? So the correct answer is 2 and 4. So this is not easy, right? This is not easy. Right? So in this exercise, we learn a few things, right? I try to warm you up of what we have learned last week, right? The table and T apply, they are doing group computation for group comparison. Okay, this is the most important thing. The table and T apply, they generate group summary for comparison, right? And when you do comparison, you need to be careful, right? Okay, if you do T apply, it's actually easier, right? Because you know that you are comparing the fraction of male of I, okay? But if you do it in table, it's actually very dangerous, isn't it? Right? It, you need to decide which way to do the proportion. And after you do the proportion, when you do the comparison, you need to be careful, right? You don't want to do the wrong thing. You don't want to do the wrong comparison. So that lead to this thing, right? Uh, it's not the case that the more data, the better. It's not the case, right? Verbals might incur confusion, right? You have a lot of figure here. Like here, we only have one number, right? And here we have a table of numbers. Right? So when we're doing data analysis, right, we can say that the data analysis is a process to reduce data, isn't it? You have a data frame, right? You reduce the data into a single number, that fit your answer, isn't it? Right? So when you condense the data, you want to condense the data in a way that you can interpret, right? So if you want to do that, the t-apply is better than doing it table, right? Because t-apply is more precise, it's more clear uh, than you do it in table, right? If you do it in table, you will need to be careful, otherwise you will do a wrong comparison, isn't it? Right? So so the reason that I want to walk you through again is in our exercise, in the 3 exercise we are going to walk through later on, you will do this again, again, and again, right? You will do t-apply and table again and again and again, right? And that is literally the most important function code in R, right? Okay. Now, any more questions? Remember, right? Remember that table and t-apply, they are doing group computation. And the reason that you want to do group computation is you want to do group comparison, right? Isn't it? Okay. So that is the key. Right? Now let's get into our 3 assignment homework, assignment notebook. Sorry. The first one is the car stolen events, right? And actually, you already have watched my uh, YouTube, right? So following that YouTube, you should be able to do some of the uh, you should be able to do some of the exercise already. So so basically, in the beginning, we just read in the data, right? Okay. The reason that I need to add this is because well, actually, the new version of R, you no longer need to use this. In the new version of R, the default is it do not transfer string into factor, right? So the reason that I'm using this is because I'm in an old notebook. My new notebook is broken, right? So you don't need to do this in your version of R. Okay, it's just as I have told you, right? In R language, it's not a formal language, right? In the formal language, they actually have a sharp distinction between string and factor, right? But in R, we kind of like intentionally blur the distinction between them, right? Okay, so don't worry too much about string and factor. Just treat them as categorical, right? Um, should be good for almost for most of the time, right? Okay. The first few questions are easy, right? Number of row, this number of variable, right? They are easy, and check the data type, right? So actually, if you were in the R Studio, uh, let me check. If you were in R Studio, you actually after you run to this point, yeah, you can actually see this, right? You can actually see the structure of this D data frame here. Um, let me say it again, right? For the beginning, for beginner, I mean the beginning programmer, uh, you should you should use a short name for your major data frame. It will save you a lot of trouble, trust me. Okay. I see people use a very long name for their data frame, and they are actually spending most of their time like correcting their spelling, right? Okay. don't don't do a very long name. You will give you a lot of trouble. So as long as you give you a short name, the function code tend to be very short and very clear, right? It's not easy to make mistake. Then we can do summary. That this is like now and these two questions they are actually the section one is actually just kind of review the built-in function code of R, right? You want to see the maximum number, you have a function called max. You want to see the minimum, you have a function called min. And where are we? Now this one. How many observations have a location description value of alley, right? How do you count this? I mean, they are talking about how many observations have a location. This location description is actually a variable, right? So they want to count. They want to count that location description equal to alley, right? They want to count this. So what is the command to count this? Yeah, you sum it, right? You sum it. Right? Now we get into the difficult things here, right? Now, when we read in the data, we will have the day and time is actually read in as a character string, right? The reason that they have to be read in as character string is like we have this one, right? Sorry, let me close this so it don't bother me. As they are because people they like time, right? Time and day in its nature it should be like a real number, right? Because time is actually in a timeline is actually a dimension, isn't it? Time and space they are like dimension, right? So they are linear, isn't it? In its nature they are linear, but in human society they are not, right? In human society, like each month might have different lengths, right? And sometimes in February you have 28 days, sometimes in February you have 29 days, right? And the way that we count the time is very strange, right? 60 seconds make a minute, 60 minutes make a hour, and 24 hours make a day, and 7 days make a week. Why? There's no reason, right? Because it's just the convention of human society, right? And that convention of human society make make the way that we record time in a nonlinear way, right? And what's worse is like actually we, we we will record the time and days in different format, right? For months, you can say the full name. You can just use 3 digit, right? You can use digit and use the same May. July, you can also say JUL, right? And sometimes there's a period, sometimes there are not, isn't it? Same thing as weekday, right? So there are so many different ways to record time. They like and day. Sometimes they have a hyphen between year, months, and day, and sometimes it only has a slash, right? And sometimes they are using like 4-digit year. Sometimes they are using 2-digit year, right? And sometimes when you say it this way, um, sometimes if they say it this way, you cannot even tell this is 2007 or 2005, right? you just you just cannot figure out, right? Even human cannot figure out, isn't it? Uh, and when you talk to time, there's more trouble. There is a thing called time zone, right? Isn't it? And even worse, some time zone has daylight saving, right? Okay. So when it comes to day and time, it's very, very troublesome. It's really a pain in the ass, right? So let's take a break, okay? Let's take a 10 minutes break. And then after that, we will solve it together, okay?